Anybody way won't fight you, man, they come, they already know. I'll be right beside you.
You're most welcome for today's session. We are still continuing with the topic of carbon and its compounds, and today we want to look at chemical properties of carbon. Chemical properties of carbon. Remember last time, the last upload, we looked at the allotropes of carbon, where we discussed the three main allotropes. That was amorphous carbon, graphite, and diamond. And we left the session with requesting you to try and come up with differences between the three allotropes of carbon. So today, still on the same element of carbon, we are going to look at the chemical properties. So chemical property number one we have to begin with is how carbon reacts with oxygen. So we are going to look at reaction with oxygen. Reaction with oxygen. We are going to see to it that there are two conditions in which carbon is to react with oxygen. Number one, with limited oxygen. If the oxygen is little, what will happen? And if oxygen is much, what happens? So with limited oxygen, carbon reacts to form a poisonous suit of carbon monoxide. Therefore, the reaction is not advisable to take place in a poorly ventilated room. I.e., our carbon, which has a symbol of C, will react with oxygen, which has a symbol of O2, and this one will give us carbon monoxide gas, which is written as that. So to balance the equation, oxygen is 2, here it is 1. That's why I've multiplied carbon monoxide by 2. It makes carbon to be 2. That's why I'm also multiplying carbon by 2, such that the atoms can balance. Number 2 is in excess oxygen. If there is plenty of oxygen, plenty of pure oxygen, we are going to see that carbon reacts to form carbon dioxide this time round. Carbon dioxide gas. And this equation can be seen in form of carbon, which is represented by capital C, reacting with oxygen, such that we form carbon dioxide gas. When you check the equation, it will balance itself because there is 2 atoms of oxygen here. Even here we have 2 atoms of oxygen and 1 atom of carbon. Likewise, the other side we have 1 atom of carbon. So reaction with oxygen, this is how carbon reacts with oxygen. We apply this reaction in burning of fuels or burning of firewood burning of charcoal, among others. So it is an exothermic reaction expected to give us heat at the end of the day. Property number 2 is going to be the reducing activity of carbon. Property number 2, or chemical property number 2, chemical property number 2 is reducing action of carbon. So carbon can behave as a reducing agent, and in this case carbon reduces oxides of metals below zinc in reactivity series to their respective metals. Before we write any equation here, we should identify the elements that are below zinc in reactivity series. To assist us in understanding the reactivity series, I request that we can use this polycarmazilic. Polycarmazilic, where PO stands for potassium, SO stands for sodium, Ca standing for calcium, M going for magnesium, Al standing for aluminium, Z standing for zinc. So from zinc downwards, those oxides can be reduced by carbon. I standing for iron, Lo standing for lead. Then we have hydrogen there, C standing for copper, etc. The rest can continue. So I'm interested in these ones. I'm interested in the oxide of zinc, the oxide of iron, oxide of lead, the oxide of copper. How can those oxides be reduced by carbon? So if I have zinc oxide, it can be reduced by carbon, and this one will give us zinc plus carbon dioxide, which is a gas. To balance the equation, we are going to multiply oxygen here by 2, because this side it is 2. It makes zinc to be 2. That's why we are multiplying zinc by 2. So expect us to request for observations. I would like to tell you that this oxide of zinc shows us 2 colors. If it is hot, it is going to be yellow solid when hot. However, it is white on cooling. When we come to zinc metal is white, so it's going to be a white solid. And carbon dioxide, we cannot see it. It is a colorless gas. However, it can turn lime water milky. So if I'm to state my observation, I will say yellow solid when hot turned to white. and a colorless gas that turned lime water milky. We are not considering white on cooling at this moment. Why? Because the condition for the reaction to take place, if we need conditions, if they request for conditions for the reaction to take place, the first condition is heated zinc to oxide. So the oxide must be heated. If it is heated, it is going to show us the yellow color. So yellow solid when hot turned to white solid, and a colorless gas that turned lime water milky. We can think of other oxides. For example, iron 2 oxide, which is written like that. Once it is reduced by carbon, we are going to see iron, which is a solid, plus carbon dioxide, which is a gas. We balance by multiplying iron 2 oxide with a 2, iron with a 2, and the equation will balance. I would like to say that this, if we request you for an observation, this oxide is black. So we are going to be seeing a black solid turned to iron is a gray solid. And then the observation of carbon dioxide will not change. It will remain as a colorless gas that turned lime water milky. When we continue, iron has more than one oxide. It can be iron 3 oxide, which is being reduced by carbon, and we form iron plus carbon dioxide gas. So on balancing, make sure you make this oxygen to be even, because even this oxygen, the other side, is in even number. So I'm multiplying by 2 to make this oxygen to become 6. I'll multiply by 3 here to make this oxygen become 6. Carbon is 3, I multiply the 3 such that carbon is equal. Iron is 4, I'll multiply 4 here. So you're going to see that carbon can reduce all oxides of iron, like I've demonstrated here. To continue with the same equations, I would like to write that of lead 2 oxide and that of copper. However, this oxide is brown, so it's going to be reduced from a brown solid to a gray solid, and a colorless gas that turned lime water milky. When we continue with other equations still under the same property, if we write other equations, we are going to see to it that lead oxide, which is a solid, will react with carbon, or will be reduced by carbon, such that we form lead plus carbon dioxide, which is a gas, and we balance our equation in that form. I would like to say that this one, when heated, it is going to be heated. It is reddish brown solid when hot, and for lead it turns to a gray solid. And definitely continue by adding the colorless gas that turned lime water milky. If it is copper 2 oxide, which is a solid, plus carbon, which is a solid, we are going to see copper, which is a solid, plus carbon dioxide, which is a gas. Balance your equation, because unbalanced equations do not score. This oxide here is black, so we are going to be seeing a black solid turned to, for girls here, they should be knowing copper girl. So this is a brown solid, copper girl. Because copper girl is brown, likewise, it demonstrates the color of copper. Then add on colorless gas that turned lime water milky. In these equations, expect us to request you to identify a reducing agent, then an oxidizing agent. So as a reducing agent, we are seeing carbon performing that role, and the oxide, the metal oxide is the oxidizing agent. If I've given you an equation that is involving copper 2 oxide, the oxidizing agent becomes copper 2 oxide. So that's how you're going to work upon it. In such equations, the type of reaction seen is a redoxy reaction. There is both reduction and oxidation. So when we continue on this section still, we can ask you to identify the substance which is reduced and the substance which has been oxidized. Make sure you can identify those substances, the substance which has been reduced and the substance which has been oxidized. The reducing agent, after the reaction, it becomes oxidized. So the oxidized substance is going to be carbon, which was our reducing agent. And the reduced substance is the oxidizing agent, which is going to be the metal oxide. So that is how carbon behaves as a reducing agent. Still, as a reducing agent, carbon can reduce concentrated nitric acid or concentrated sulfuric acid. But these reactions, they are going to be handled more when we come to the respective acids. However, I would like to say that with concentrated nitric acid, if that is our acid, carbon is to reduce it to nitrogen dioxide and water. So nitric acid, because it is concentrated, you can represent it with the Na state, aqueous or liquid, plus carbon. This one will be oxidized. Carbon is going to be oxidized to carbon dioxide. However, the carbon reduces nitric acid to nitrogen dioxide and water, which is a liquid. So if we come to balance our equation swiftly, begin by this oxygen, which is in odd number, make it even. So I'm going to multiply by 2 such that the oxygen, all the oxygen this side is in even number. Hydrogen becomes 4. I come to nitric acid and multiply by 4. Nitrogen becomes 4. I come to nitrogen dioxide and multiply by 4. Oxygen becomes 12. These are 8 plus 2, 10 plus 2, 12. So my equation is balancing. Expect us to request for an observation. I would like to say that this one is a gas that has color. So it is a reddish browny gas. So tell us the reddish brown gas was formed. Number 2 is reaction with concentrated sulfuric acid. With concentrated sulfuric acid. If I have my sulfuric acid 98% concentrated, can represent it with the liquid state. This liquid can react with carbon because we are looking at an equation where carbon is a reducing agent. So reacting with carbon, we are going to see to it that sulfuric acid is reduced to sulfur dioxide and water. Then carbon is going to be oxidized. Carbon is going to be oxidized to carbon dioxide, which is a gas. So after that, make sure that you balance your equation. We are beginning with water to put a 2 to make this oxygen even. Hydrogen has become 4, so I'm multiplying sulfuric acid by 2. Sulfur has become 2, I'm multiplying sulfur dioxide by 2. Oxygen is 8, these are 4 plus 2, 6 plus 2, 8. My equation will finally balance. Both gases have no color. This gas does not have a color, even this one. So we are going to see colorless gas that turns acidified potassium permanganate from purple to colorless. So those are the chemical reactions of carbon, and that is how we can describe the chemical reactions. The next upload is going to be handling compounds of carbon, and under compounds we are going to begin with oxides of carbon. I would request you to continue subscribing to my channel. Watch these videos and pick out the information that is very crucial for your understanding of chemistry. I thank you very much for attending and watching this.
First let me say to you, I cannot wait to see you.